Welcome to this new lecture of natural language processing. In this lecture, we will learn Zipf's law. What is Zipf law? According to Zipf law, the number of times a word occurs in a corpus is inversely proportional to its ranks in the frequency table. In simple words, if the words in a corpus are arranged in descending order of their frequency of occurrence, then the frequency of the word at the ith row will be proportional to 1 over I. The formula of Zipf law is frequency of a word is equal to 1 over rank of word in vocabulary. This also means that the frequency of the most frequent word will be twice the frequency of the second most frequent word. For example, if we look at the Brown University Standard Corpus of present-day American English, the word "the" is the most frequent word. Its frequency is 69,971, while the word "of" is the second most frequent with the frequency of 36,411. As we can see, its frequency is almost half of the most frequently occurring word. To get a better understanding of this, let's perform a simple exercise. In this exercise, we will plot both the expected and actual ranks and frequencies of tokens with the help of Zipf's law. We will be using the 20 news groups dataset, which is provided by the sklearn library and which is a collection of news group documents. Now we start our programming exercise. First, open a Jupyter notebook and second, import the necessary library. First, we import the PyLab library, which is used a drawing library or drawing a different plots of different plots, and then we import our natural language library NLTK, and then we import the stop words, and then we import the stop words, and then we import the fetch underscore 20 newsgroups dataset from the sklearn.dataset package, and then we word underscore tokenize method from NLTK library, and then we download the punct algorithm, which is used for tokenizing the word of a sentence, and then we enter the list of stop words from nlt.corpus package, and then we import the RE regular expression package from Python language, and also we import the string package from Python language, and then we also import the counter class or function from the collection library, and then we at the end we import the matplot library for drawing different plots. In the next cell, add two methods for loading stop words and the data from the newsgroups underscore data underscore sample variable. Now we start our first function, which get the stop words. Stop underscore words we call stop words word class and its function words, and English its mean we download all stop words which are all English language stop words, and then we store in stop underscore word, and then we extend our list of start underscore word by using the string.printable functions. In printable function, we also add some stoppable words like punctuations, digits, ASCII letters, and white spaces, and then return stop words list. Now we get and prepare data And now we define another function which name is get and prepare data, and our parameter of this function is stop underscore words. And then we declare a variable news group underscore data underscore sample subset fetch underscore 20 news group grab us 20 news groups, and its parameter subset set to train. It means we download the only training part of data set, training part of news group data sets. So this part of training part of data set stored in this variable news groups underscore data underscore sample. In the next line, tokenize underscore corpus. Actually, the result of this all codes is in type of return in type of a list. Now this code we understand a line by line. Okay, if you see first you see in this code there are used two loops, for loops in this codes, and then one if loop, then one if condition in this code. So we understand these two loops and if conditions one by one. First for loop actually get the sentence from our data sets. It means our data sets consist of many sentences, and then we extract each sentence by using this for loop, and then these sentences, words of these sentences, actually letter of words of these sentences, we convert into lowercase letters. Okay, and now we see the next for loop. This for loop actually extract the all words from the above sentences. You can also say this for loop extract or draw the all words available in the sentence, and according to this regular expression, and at the end this if condition is used to stop words in the words list. It's mean by using this if condition, all stop words are not included in our list of words of the sentence of the corpus, and then return underscore tokenize corpus. So we run this cell. Okay, there is a further little description of the above function. Example, get underscore stop world load stop world list from NLTK data, and then get underscore prepare data will load the 20 news groups data and remove stop words from it using the given stop word list. Add the following method to calculate the frequency of each token. We define a user defined function get underscore frequency corpus. The first parameter is corpus, is our corpus, and n is actually n means how many words I have to return the frequency of words, the frequency of word, how many words which we want to return their frequency. Okay, now we have a variable token underscore counter id counter comma counter of corpus. It's mean counter function count the words of corpus words. So actually counter word of corpus count the frequency of words present in the corpus, and then return it most common n number of words. No, call all the preceding methods to calculate the frequency of the top 50 most frequent words. First, we load the star words list, and then we extract the all unique words from the corpus by using this function, and then we get the 50 words along their frequency. So run this cell. Please run this cell first and then run this cell. Okay, so it means there is some problem. Okay, star words are not here. Actually, I think first run this cell. Okay, our required packages or data downloaded successfully. Now run this cell. Okay, please wait, extracting the words from corpus. Okay, this is the output of our above three functions. Oh, it returns 50 words and their frequency, and in tuple format, and all tuples enclosed in list data structure of Python. And inside Python, each word in tuple format. It means its first element is the word, and its second element is the frequency of this word. It means AX has this frequency in the corpus, and EDU word has this frequency, and subject has this frequency, and so on. Actually, frequency are managed or stored in this descending order. So in the next cell, we run this cell, and then we explain this the code of this cell. Okay, actually this is actually our actual frequencies, which is in log form and scaled by log form, and this is our Zipf loss frequency. This whole cell actually this cell actually calculate the original actual frequency and then frequency by help of or by using the Zipf loss. So this we use the same corpus, but now we select 1000 words from this corpus and their frequencies, and then we apply Zipf law, and then we draw the results and results in the form of graph, where actual frequency is this and Zipf law frequency is this. So thank you very much. See you in the next lecture.